Thank you very much. I'm proud and very happy to be with you today with the future of the world, so it's quite an honor. I have a presentation in 15 minutes and we do like the birds and flock off, or 4 hours with standing ovation. So you will pick during the presentation. I'm not 100% fluent in English, even though I'm from Montreal. I'm French Canadian and I've been here 20 years, so I'm stuck here since 20 years. And I'm trying to survive in Paris. So the subject will be much more onto microeconomics because of my engineering background. So I'm a building engineer, an infrastructure engineer. I've built many infrastructures, schools, hospital, and I've also worked into maintenance, operation and maintenance. So I know a lot about the whole life cycle of an infrastructure. And those infrastructures led me to do my Ph.D. in economics because there's a strong link between those two. I hope you will be convinced of that at the end of my presentation. So I'm, like it's been said, I'm a professor at UTC, but I also had a startup. In 2011, we were alone, me, myself, and I. And now we're 75 engineers in the company between Paris and Montreal. So we're trying to change the world in our small company. I'll talk a little bit of few results that will come from that company. Few quotes to start. The first one is linked to the question for that American lady who asked a question about nature and can we have law for nature. The presentation was actually great from the colleague from Columbia. This quote from an American environmentalist, Richard Heinberg. In the end, nature always bats last. Bats in the baseball, the last who bat may make the game over and win the game or lose the game, but it's supposedly to be the best batter. So the nature will at the end strive and will be deciding for us, either if it's with meteorite and destroy us from other world, or maybe killed ourselves with poor management of environment. We shape our buildings and afterwards our buildings shape us, or infrastructure, from Winston Churchill. What a hell of a guy to have into a seminar on sustainability, but actually he's right. He's right, because you're going from here to the airport by a highway that was decided by the government, that was built by constructors, and you have to go that way. Cities are built so you walk more or you walk less, you use more your cars or not. So that reality is absolutely strong and right. Cities get to have a lot of emission of CO2, 70% of the emission. Buildings only, it's 40%, the rest is with cars and industries. A city built on concrete is not a city for people, it's a city for machines. We know that we have built our industrial world since 150 years with the machines to replace man and woman, to replace slavery by machines. But we have now the reality that it leads us to destruction, auto-destruction, maybe. And I like that Chinese proverb, the best time to plant a tree was 20 years ago, which is pretty true. The second best time is now. So if we wonder what would be the cities and the buildings within the next 50, 100 years, we can imagine, like on the first photo, that we change the existing infrastructure into partly gardens, having more biodiversity coming back, maybe less heating because of the green that we will put in. Why not? It's a possibility. It's low technology, and we can maybe implement that everywhere. The other one, in bigger cities, we can use roof, we can use walls, we can embed the solar system panel. We can imagine many things that could be soft, but everything behind that goes with what you just saw, the problems with the law. Who pays and who is responsible to maintain within the life cycle of that infrastructure. Most of the project we did in France with green roof and green walls in the last 15 years are gone to waste. Dead. Nobody to maintain the infrastructure. So it's a very, very hard problem to think into life cycle when we design things. So whatever you do as a policy, if you don't include the aspect of the life cycle, you're done. You're going to do full paradox over the time. Or we can go into techno-solutionism, so to very high tech, like that building in Amsterdam. So some of you come from Netherlands. You know that building? No? It's a very original building, built in 2015, 14, 15 to 16. 40 square meters, to imagine what is 40 square meters. Primary school in your cities is from 500 to 2,000 square meters. So you can say it's maybe 8 times primary school in your city. And they have more than 28,000 sensors. So this is a nervous system that makes the building work. No nervous system, no ventilation, no electricity, no nothing. So you need those sensors. You're dragged on those sensors. No more rare hurt to make sensors, and you're done. So very, very interesting to wonder, should we design buildings, because I show you a building, but more and more infrastructures, also bridges and everything, are going that way. Engineers don't know what to do now. They don't construct anymore, especially in the Western world. It's not true in other parts of the world, but they're not constructing much into the Western world. So what are they doing? They are trying to find work, to have a repeat business into existing infrastructure or new infrastructure that will need to be fed with technology more and more and always. When I saw admettre, I don't know if I'm doing the good things, but somebody got in. So we'll talk about that building at the end of the presentation, and I will ask you what you want to know about what you think about that building. Oops, put that there. So the first part of my presentation will talk about ecological challenges we face. Most of those challenges you have seen before in other presentation, so I won't go too far in it. I don't waste your time on that, but it's important to assume my presentation that you understand what I understand. So you might know more than me, and it would be perfect. So climate change and increasing carbon emission is a fact. Depletion of natural resources, you know about. Environmental impact and population is growing, so we have more urbanization more and more. And new language to challenge economic growth. Though we can still talk about capitalism. I will tell you what I think about capitalism at the end, but I'm a North American, so don't forget that in my presentation. I'm not Trumpist, but I'm a North American. So the population you have when you do your policies and you have to manage infrastructure, you have to know about the demography. What will come? Will we need hospitals, bridges? Will we need schools? Will we need industries implemented all over the country, all over all over Europe, the continent? So we have to look at the shift of population. For example, within 2100, we will have more than 60%, maybe 65% of the population. Right now, we are at 55% of the population into cities. So that's a big, big, big challenge. How do we get together all those people with the need for food, the need for water, the need for air quality? India will go up maybe to 1,400,000,000 persons, so it's going to be the biggest country in 2100. China will be stepping down from 1,400,000,000 to half of it in 2100. There's a decrease of population in China, so it will be maybe 700 million in 2100. So it gives a hint on what we should do with infrastructure and how we should think about infrastructure. In the Western world, we'll stay at the same level, with Europe staying alike, and maybe a little growth in North America with immigration. Africa will go up to 2 billion person. So those population shift at a global level is important, but at a local level also is very important to manage, to measure, and to see where it's going. Not easy task to do, not easy task, very hard to do. Here you have the natural dynamic system that you can add more parameters than those here, but we know that the land is less and less available with the city growing and having more people on the planet. So that gives us big interrogation marks with agriculture and transport, for example. We have an increase in paper consumption, so no more forest. I will do you now, because you are special people, my personification of the Amazonian forest. You want to see it? You ready? 1, 2, 3. Deforestation. So, just another anecdote. As I was an engineer at l'École Polytechnique de Montréal in 1990, 35 years of experience almost. One of my friends got into the paper industry, paper and carton industry, and he was crying, saying, "What will I do? I will have no more job within few years because we are going to digitals and we will not need any more paper." I saw him 20 years after. He was fat, rich, with a cigar, saying, "Great, people print things all the time because of digital, so I sell more paper than I ever did before." So he's now rich with selling more paper. Increase in drinking water for sure, so there will be a pressure more and more with water. Increase in digital would lead to a problem with extracting rare earth oxides. You know where you extract the most rare earth on Earth? China. 80% to maybe 90% of the extraction is in China. So we are friends with Chinese. We like Chinese. They're very, very nice people. Because if they want to change their way to negotiate and their contract and their policies, you might be in trouble to work with them. So we have to be friends with everybody. Steady increase in production of vehicles, fossil fuel vehicles. We have more population. And the paradox is that we're still constructing a lot of those vehicles, if you look at the numbers. And it's known that we won't have enough electricity to have all electric vehicle, EV. It will not be possible to have that in many countries because of the lack of electricity resource. A sharp increase into primary plastic production. Still, we have a lot of plastic, even though we try to change to les alga in English, I think. We try to switch plastic with natural materials, but it's not easy. It's not at big scale, so it's not possible now to change everything. And we don't very know how to recycle. They're recycling a bit into everything that is thermodurcissable in plastic. They recycle it into chairs for garden, table for garden, things like that. But it's a small market. And the big problem, we have problem with CO2 because of oil, natural gas, and coal. Very, very hard to get away from that because our economy is built on that. 80% of our energy is coming from this. So we have to take that in consideration. And to see the implication of one on the other, you have those two graphics that are very, very compelling. The first one is about CO2 with GPD. GPD is the growth indicator for economy. And we see that there's a straightforward correlation between the two. So we cannot have a growth in the economy without having CO2. And if you look at the other one with the energy and GDP and energy, you see the same result. Same. Actually, it's a causation. It's not only a correlation. It's a causation. So we see that there's a link between energy, which are linked to CO2 a lot, and GDP. Look at those points here. They're very interesting because they're coming back. Less energy, less GDP. It was the COVID. Those 2 years were the years of the COVID. So you saw that we should have a COVID every year, maybe for the next 50 years to get back on the train. So what will you do? You would have more debt because most of the government went over the COVID with having a bigger debt. So it's a real problem of capitalism in that matter. We also have strategies that have been led by the standard boards with accounting. So accounting is a big issue within the sustainability. So we have two main tools for accounting. We have the balance sheet. This is a financial tool to see if we have a company or an organization, public or private, who is steady and in good shape. And we have also income statement. Those are the two financial tools you have to monitor the quality and the perspective of an organization. But now, since 2023, June of last year, those boards, especially the IFRS, are thinking about the 6 capitals. So they have identified capitals that would be other things than money, so linked to nature, whatever. You can go drop that into Google and look for 6 capitals from IFRS, and you'll see there you have pretty interesting stuff, but very hard to use. And I'm writing an article right now about the difficulties. The difficulty into those matters is always the negative externality of one measure to the other, the complexity of the intertwine of things. So the third tool, I talked about the balance sheet and the income statement. The third one is extra financial ESG, environmental, social and governance criteria that companies should implement, so you have a better understanding of the company or the country or the public organization. The problem with that, I will tell you, 2 problems. First problem I talked about is about the external negativity, the thing that you put on the shoulders of others, and we'll see things in a few minutes. The second thing would be that most of the project right now, it's the far west, so most of you are going to work into that field to try to have those criteria and to try to measure them. I looked a little bit at your profile on internet. By the way, if you want to stay friend with me, you have to decide only at the end. Maybe you won't be happy. My email is at the bottom of every slide, and you can go on LinkedIn. You'll find me very easily. So the problem with those criteria is the problem also of the scale. Most of the company now will go with the big 4, EY, KPMG, Deloitte, and they will have, I would say, friendly report, looking at a small project in a big company. We did a building like the Edge building in Amsterdam with technology and everything. So on our criteria, we're very good. Invest in our company. So this is kind of a mask. It's not maybe the reality, because the scale is not a good one. It's a too small scale. And the other aspect is the life cycle. I talked about it a few minutes ago. If you say we will do green roof everywhere, we are Walmarts. We're going to do green roof everywhere, but after 3 years, no more roof, because we didn't maintain it. So Walmart is not good anymore. So those criteria, if they're not measure and look for many years on the life cycle, it's not worth the trip, or it's on the beginning. So we're at the very beginning of this. And to show you an example of that problem, you have here Western countries, US, Germany, France, UK, and on that study, you had a clear demonstration that they were good students. More growth in red, and less consumption of CO2. Wow, wonderful. Can you explain me the problem of scale that we have there? Yes, actually, yes. The perimeter of the study exclude the fact that you dump everything in Asia, for example. So Asia has been consuming more, like we saw when you look at a global level, at the level of the planet, and when you look at the level of a country, so let's say at the level of an organization, you have the same kind of result there. So the scale is a really big problem into those ESG criteria. So if we sum that up, those facts, capitalism, which would be a construct over human capital, natural capital, and what we do with it, so productive capital, has big challenges, especially to confront growth with the non-financial information. Are we still going to be in growth forever? Should we think into circular economy, which I think will be the future, circular economy. Maybe slowing the pace in growth, maybe dropping the growth, and going into circular economy. But I won't get into that rabbit hole now. It's a 2-hour special if you want it next week. So we have 4 main facts that we can think about. One of the big problems of capitalism reporting is about the dislocation between depreciation, which is the way organization will look at amortization of infrastructures, the depreciation, and the degradation of infrastructure. To make you understand, this building here, for accounting, accountant, is depreciate, let's say, over 40 years, 50 years, 40 years, whatever. Actually, you have to be more specific, a rule now that you depreciate by component or by element, but I won't get into that. Let's say 40 years. If you've gone into the corridors, went to the toilet, especially the men's toilet, you understand it won't be there in 40 years. The degradation will be faster. It's a very, very poorly built building here. It's not a high-quality building. As an engineer, I can confirm that. So we will have difficulty to make cohabit depreciation and degradation. That's a big, big, big challenge. So you need to put more physics, natural resources and human resources into depreciation, which is based usually at the beginning in the history it was based on reality of degradation, but more and more it's been dislocated and it's giving pretty bad reporting. The other idea that we should seek a 25-year time frame to identify the needs is very theoretical. Very, very hard. It's still something you can imagine to try to forecast, but we'll see that there's other consideration that we take in purpose. The empirical time frame is 5 years. A general trade, an engineer, an architect, an urbanist will be able to talk about his object, physical asset, over the 5-year span. What will happen, what will become, how the degradation will be working. Even though we have to project ourselves as human over maybe a generation, 25 years, to imagine what will be schools, hospitals, infrastructure in the future. Those are conceptual and theoretical aspects. On the reality of day-to-day degradation, it's a 5-year span that is interesting to look at. So the big question, like I told you, what is value and what kind of value we should use with such a complexity? Actually, we have the classical market value, like you guys know, what does cost that building here on the market? Price, or is it price? Book value is linked to the depreciation of the object. And usage value, we'll see what it is. But usage value is my proposition for you to keep and get with you to maybe monitor more easily what's going to happen with the infrastructures and the organization within the infrastructure. So what does value means? Value is not only economic, it's also about social, so enhanced quality of life, community well-being, this is very important, and environmental criteria. So it's not only about economics. It's the big problem in the last 30, 40 years to have concentrated, especially with the economy all over the world, to spread the only rule of market. So you have to see your organization who's managing infrastructure, either it's a city, a country, a private organization, as a system, like in engineering. You have input, you have outputs. But during that transformation, you have a lot of breaks. A lot of people want you not to do your project of transformation, leading to better quality of life, better environment. But you have also enablers that will help you. And at the end, you have, whether you like it or not, it's the big paradox, even you have a result and output, you have outcomes, the consequence of what you did. You produce more shoes, maybe your numbers are going to be up, but you maybe are going to have more CO2 in the environment. So the outcomes would be more pollution, for example. I would let you read that at home when you will recuperate the PPT if you like it. But you see two aspects very important: culture of the organization and culture of organization. It could be either a brake or an enabler. So if we just make a little spotlight, you see that in our organization, it's true with infrastructures management, so physical asset management, but it's true also with other decision making into the organization you will work in the future. You always have difficulty with participatory and or authoritarian. Should you go for it with the law enforcement and whatever that lady said before from Colombia, which were absolutely right, but it will be leading to questioning and maybe to a revolution or not being happy about the situation, at least. No acceptance in a way, if you don't make people participate in the decision. Are you going to go straight forward without thinking too much and maybe inducing new paradox? Or are you going to go with maybe more cautious and with uncertainty and difficulties to follow up with that uncertainty? And what about short-term and long-term orientation? So what is the result we seek or the method we seek? Result and method is two different aspects of that short-term, long-term orientation. And with the information, is it collective or should we share or should be individual and maybe close up to decision makers who will decide for everyone else without asking people? So that leads to a proposition that I give you to look at infrastructure with the prism of usage value. So what is usage value? One of the models that I have determined that I use in my company, so you can have it there, it's free. If you go in on HAL, H-A-L, Jean-Pascal Foucault, you can have my thesis, and it's also free, 2 chapters about the solution, so go for it. The idea is to see if we are, to monitor, to have a KPI, to see if we are into an ideal place, or we need to do something to maybe retrofit the building, rehabilitate the building, the infrastructure. And to go for this, we will have the benchmark of the current replacement value, which will be the usage value. And the usage value will be based on if we should have a university like we have today, what would be the same usage, the same technology, the same, so you question how you design the building and for what life cycle. And when you have looked at the price of that building, the cost, I would say, of that building, you compare it to what you should implement in that building. So what is the list of what you would have to do to retrofit that existing building towards the benchmark you have. So the indicator would be CN5 divided by CRV, and you would have a percentage indicator that will give you either it's an ideal situation, suitable, tolerable, or worst. With that model, we find out more and more, especially in Western countries, that almost everything is built. It's only less than 5%, 3 to 5% of infrastructure in Western countries are new. Most of the infrastructure are existing. That's the first thing we should know about. Second thing is that we see that there's a lot of obsolescence. We did not do well with operation and maintenance in the last 30, 40 years. Since the war, since the Second World War, we did not do well. We construct a lot without thinking about the life cycle. So we're now having a lot of 15, 30% buildings and infrastructures, and maybe worse. In the US, for example, the bridges are in very, very bad shape. It's a very, very big concern. So when you think about a high level of cholesterol, if you want to use the metaphor, the doctor, it could be kind of a cholesterol with the asset condition index, a cholesterol level. The more the cholesterol is, won't say you will die of a heart attack, but there's a risk. So straightforward, we have to think about risk. And now in Europe, to give you an idea, for 100%, so if you have 100 millions of project construction, rehabilitation project into existing portfolio, you have less than 15% of the money to do it. So I repeat, you have only 15% of the financement to do the rebuilding or the rehabilitation of the bad buildings. So you lack 85%. So those 85% should be risk managed. So one of the main concerns is risk management for the future. So I have here the definition. I won't let you read that. You will read that tonight, or thinking of me, or during your flight whenever you go into vacation, wherever you go. But those are the specific definition that you can find also in French in Might Easy. You have other parameters that you have 2 chapters, more than 200 pages. So I'll let you read that and ask me question if you want. But the idea is for a portfolio, and here you have a portfolio of an airport portfolio with many buildings, 2 million square meters of buildings, and it includes also in that representation the infrastructure of the tarmac, the place where the airplanes move, and at first we see that for that portfolio of 40 years, so those buildings were built 40 years ago. Those were built more recently. And you have the ACI, so the higher, the worst. And you have a cognitive bias that is really often seen into those portfolio. We think that we can make a rule of thumb and maybe go with young and healthy, elderly and bad shape, which is not true. You have elderly in good shape, and you have young who are in bad shape. So that's the first thing you should remember when you're auditing a portfolio to see in which shape it is. You have the cognitive bias to manage. It's very important. It's one of the big pillars of your any audit that you're going to do, financial or technical or environmental audits. You will have to think that you have cognitive bias that you have to fight against. The other important thing is that you will never have all the information to do your audit. So you have the second pillar of any audit would be the bounded rationality approach of Herbert Simon. So bounded rationality and cognitive bias, which would be more Daniel Kahneman, the Nobel Prize in economy, who did a book, a very soporific book of 560 pages called Thinking Fast and Slow. And at the end of the reading, you think slow. So here's a representation of a decision-making tool for the airport management to decide what money they need to keep their infrastructure at a good level. And that implements, because I saw in some of your eyes, why an airport? It's not a good thing in airports. It's not sustainable. You get the decision makers to think about the future of the airport. What should we do? Should we grow? Should we be a hub for a bigger worldwide approach? We're discussing with other airports in the country or in the continent or in the world. So there's a lot of policies that you can deduct from that kind of situation. Here you have almost 2 generations. A generation is 25 years. A life cycle of 2 generations is where you have a point, a very focal point of deciding what we should do for the next step. Another example here. So the first one here, just to let you know, you had the usage value that was high, because the loss of value was low. and then the usage value decrease. You have the same graph here, but the other way around. You have usage value that will decrease over time. So you have here two hospitals, A and B, built the same year, in the same country, with almost the same design, same operation mode for construction, and almost same financing for operation and maintenance. But you see that the green one is better than the purple one. Why? So one of the two buildings is getting worse, has a bigger loss of value, of usage value than the other one. Why? There's three main factors, three main class of parameters that influence that. First is the quality of the construction and the quality of the materials, the system that were chosen, and the implementation of the building on a neighborhood, into a neighborhood, for example, with the sun impact on roofing or whatever. Is it more rainy in your place? So the design at first is the main concern about the degradation. It's the heredity, if you take the analogy with medicine, it's the heredity of your infrastructure. Here you had two buildings with almost the same design, almost the same quality of construction. Second class of influence for degradation is level of service, level of effort for maintenance. So do we do a steady, very regular maintenance, or do we do a renewal of system that is very lazy? That's a big difference. And the third class of consideration is the exogenous phenomena, for example, climate change, for example, pollution, or the endogenous phenomena with usage, quality of usage, frequency, number of hours the building is used, or the number of trucks going on a bridge or whatever. So the measure of the usage of the building. So those three classes of parameters are very, very difficult to find for engineers. It's a field of research right now, which I'm contributing. We hope we could have a book we open, and like in Hollywood, having a building destruct live under your eyes by simulation, but it's not as easy, because those three classes of parameters are linked to other considerations that we'll see in just a few minutes. So you had poor policy for asset management on the purple one, and good policy for asset management on the green one. This is what you can see. And those policy, based on studies done in the 1980s by Howard Resnickov, a mathematical genius from Harvard, who observed many maintenance policy, and at the end, after using many models with probability and very hardcore mathematics, he found that the solution for good maintenance is only willingness and responsibility. Willingness and responsibility. And this could come with law. If it's mandatory to do something, people might do something. But willingness and responsibility was the key thing to have a good policy into maintaining the organization capability to have a school, to have a university, to have a hospital. So interesting example to show that combines the life cycle consideration and the loss of value, loss of usage value consideration. So why a metadisciplinary approach? So how can you have, so meta in Greek means over the other disciplinary. So it's not another disciplinary within those existing. It's looking over and having maybe silo going down to integrate the information from one another, to have less externality, negative externality from one silo to another silo. So it's trying to see through silos. So another consideration you should take in concern when you are working into infrastructure is at which organization are you what kind of organization do you have for governance level? So I would say more than capitalism, the life cycle of government level is a real question mark for me. Is 5 years in France for the president long enough? Maybe it's too long, I don't know. Is 3 years would be okay, 4 years like in Canada, maybe 7 years like it used to be in France? I don't know. But one sure thing is that a minister in France is average 2 years. So within 2 years he wants to make decision to live forever in the glory of France. But the reality is that the infrastructure live longer. So the infrastructure will go over time, not the politician necessarily, but we know that they keep on moving in the same fishbowl for many years. The other aspect of the design of a building within an organization, so either if it's private or public, you have decision making cycle at the level of the governance. When you design as an architect, you think in generation. For example, in a small density city in France or in Europe, a primary school will be used for maybe 2 generations, 50 years, over 3 generations, 75 years. After that, we don't know what to do with that school. You have elderly people around. Maybe you can shift that into an elderly home. Why not? So you have to think about the future within the perspective for school, for example, of 50 to 75 years. It is well documented. But in many other fields, we should know about those life cycles to forecast what will become after that. Will we have maybe recycling of the old building, piece by piece? In construction, you recycle less than 5% of the components in a building, for example. Very, very low recycling. Very bad, very bad. So that life cycle of 2 generation or 3 generation in a high density city like Paris, it's 100, 150 years. It's much, much more because of the density. So you see the link between usage value, density of cities, urbanization, population, recycling. I hope it appears in your head slowly. And then you have the forecasting of future life cycles. So the component and his for example, the lighting, the walls, the concrete, the quality of it and how it will stay. It is determined by the industrial life cycle. The big problem with industrial life cycle is that it's based on legal perspective, law perspective. What I mean is that if you ask someone who built a roofer, how long will last your roof? He will probably say to you, well, do you want me to have to guarantee it, to have a warranty onto that roof? If you say yes, he will say half of the real life cycle. He won't tell you that he think like that, but he will say 10, 15 years. So the life cycle is shortened a lot because you want it to be with warranty. If you ask him saying, I don't want warranty, I want the real life cycle, he will tell you maybe 80% of the real life cycle he have observed in his many benchmark. So if it's 30 years, he will say, well, maybe 25, 24 years, 25 it will be okay. So what we know now is that with the industrial life cycle, we have shrinked the time we should redo and retrofit the building. So if you use a theoretical life cycle based on the industrial life cycle, you're wasting more and more construction and more natural materials within, and more energy is spent. So it's a field of research for me also, those life cycle. How should we treat that, and how should we consider new kind of life cycle? So you are into a very complex system, very dynamic and complex system, where it's not only looking at the infrastructure as an engineer, it's looking at as a politician, an economist, and a environmentalist expert. So what would look like at a micro level, any organization that you will have to deal with when you go with infrastructure? So don't be Don't be flabbergasted by the representation. We will do it slowly. So it's a big system that you see. That's an organization, let's say Université Paris 13, or City of Paris, or whatever organization you want. In that organization, you always have input of information and output with decision making. This is the nervous system and also the digesting system, the anatomy, the physiology of your organization. And within that organization, you have 4 different subsystems. The first one is strategic subsystem. When we talk about strategic, it's about what we want the university to be within 5 years, 10 years, whatever. So do we want a new laboratory on a very special aspect that nobody does? So it's very important to have you can send it to my mother if you want. Yeah, it's why I was there. You're gonna have the slides, huh? Don't worry. You're gonna have the slides. Don't worry. So at the strategic level, it's asking the organization what is the purpose, the objective that we seek for the organization, and is it bigger than life, or is it linked only to the existing infrastructure? Bigger than life would mean that we need to construct more square meters, for example, and having a project within the square meters we have is very different. For example, many years ago at Université, technologie de Compiègne, at UTC, the general manager of the university was looking for 2,000 square meters. And he was saying it's not fair, the region don't give us the money, the country don't like us. He was not happy, and I raised my hand and I said, I will give you a solution that you will construct 0 square meters. He said, well, he took his pen, said, tell me, Jean-Pascal. And I said, you only have to open your school from 7 p.m. to 22 p.m. So 7 to 10 p.m. And you're going to have students all over evening in your school. You will recuperate 20,000 square meters, which is good. It's too complicated with the students won't come, the professor won't accept it. It's true, you need to negotiate something else. Maybe it's not a good solution, but it was a solution without wasting the environment. You catch my drift? Oui. So the first thing is about strategy. The second thing, so it will lead to a master plan. Infrastructure master plan, real estate master plan for buildings. It's the main tool that you will have when you want to decide what you're going to do. You're at the level of the objective of the organization. The second subsystem would be tactical, would be the distribution of resources, human resources, material resources, financial resources between capital expenditure, CapEx, and OpEx, operational expenditure. That will lead you to a multi-yearly plan, investment plan for your, this is concrete stuff that you're gonna do in reality. And the third subsystem will be about the operation done, the task done, objectively, factually, onto the field. Do I retrofit asset? Do I construct new square meters? Do I maintain only for operation and maintain, so quality of life? And I measure whatever I can, what is relevant to have an overview of my system. And then you have the last one, the subsystem, which is the oil of today. The oil of today is the data that you will have into any system. So right up there, I showed tools that we usually use into the different part of the system. But more and more, you have specific physical asset management software, like the one we built in tbmaestro with engineers, to implement new information to the decision-making core, to have maybe a shift into the strategy and maybe have the university open from 7 p.m. to 10 p.m. to construct less square meters. So it's a shift for engineers, but also for economic people, environmental people, and politicians, to shift from the vision of a project, a construction project, which is over a few months to 3 to 4 years, maybe. Big projects, maybe 4 years. A new, very, very big 4,000 square meters, 40,000, 400,000 square meter would be a big project. So we should more and more include into our decision making to be able to master the environmental and sustainability, the whole life cycle approach or thinking or what we should do. In 2019, I was a court expert in Canada for a private finance initiative hospital, so a private build and finance hospital. And the judge was asking me, is it less costly to do it the old-fashioned way, traditional way with engineers, architects, and financed by the state, and we manage the maintenance by the state, by the government, or should we do it by private sector only? What is the less costly? And the answer was, I lost air. Actually, it's very, very complex to put the hypothesis and the condition of operation here, but we could see that, especially only with the financial, the mathematics of financial, with the discount rate, for example. Just switching the discount rate from 6% to 8%, you turn around the decision. So my conclusion was the decision is not about money, it's about what you want to do with it. So what is the condition of environmental aspects, sustainability, everything? Is it taken in consideration? Will it be really sustainable, or will it let it go away without taking care of the building? So we have to shift from the tree, what we call the Americans call the triangle or the triple constraint triangle. So cost, quality, and duration into 5. So quintuple constraint. Cost, performance of what you want for the systems and the building and the infrastructure as a whole. Risk, life cycle, and usage value. So that shift is not there yet in many organizations. So you are at a starting point with us with that. So how do we think or discuss about value when you design a building or when you have to retrofit over the time after 10 years, 15 years, 20 years? I have imagined that representation, so if you're not happy, you have to tell me. I'm the author of that representation. You have 3 aspects that you should look at first. You have into a physical asset, the usage, so what you're going to do in many parts of the infrastructure. The second thing, you have the features that you have. Don't look at the split right now, just look at the term feature. And you have the functions. Those are the 3 concepts that you have. If you have a breakdown or a rupture of the usage, so the usage is not good anymore, you should shift to another usage. If you have a breakdown of the functionality, so obsolescence, or a regulation that will lead you to a change into a system or components, or if you have a rupture of function, you will have to do a project. And it's where you have the 100 million stack of project I talked to you about. When you look over and audit a park with those 3 concepts, you will have all the project you should do. Then you have only 15% of the money to do the thing. So you have to manage the risk. So if we look further into that thing, the main concern that I will ask you to think about is with the new feature, the new functionality you will get into the building, you will have to think about low-tech or high-tech. Should I go with the edge building in Amsterdam with many sensors everywhere? Or should I go with a lot of inertia and maybe have a better life cycle? There's no better life cycle than a rock for thousands of years. And so test of sobriety of techniques and technology. And the ambience is all about what you need as a user into the building. You need heating or cold during summer. If it's too hot, you're going to have air conditioning system maybe coming from those pipes. And there's 8 main ambience. I won't go through all of that, but you have to look at that. Just to drop them very easily. All about air tightness and water tightness, and heat tightness or cold tightness. So it's all about the building envelope. So is it well designed, well built? Should we add isolation to an external wall, for example. The problem with capitalism is that they will ask you what is the ROI, return on investment, of an external wall isolation, and it's 30 to 40 years. So you make a straight hard attack to any financial person that hear that, they say it's too long. ROI should be 2 years, 3 years, maybe 5, 10, oof, I don't know, 40 years. But if you tell him that the wall would be there in 70 years or 60 years, 40 years, not that long. You see, you should adapt your speech to the people. Indoor quality, lighting, acoustic, safety of people, safety of building, hygiene, sanitation, and aesthetic. Aesthetic is ergonomy for the psyche. Huh? You know that? Oui. In many parkings in France, they only have painted all the walls, the gray walls of concrete walls. They have put Mozart, little music, and now most of the people feel safe. But it's the same space and the same danger. So it's about what it makes to your psyche. So the system I have designed, and I don't know if I'm exploding the time. I'm way too much. 10 minutes? I'll do 5. No, I think it will be 15. Okay, so the system I have designed, and you will find that I've called it a packet process on asset for criticality and knowledge by inspection. So the technical aspect, I did a little I because we put too much emphasis usually on those aspects, and testimonies, the social and human aspect of it, the T. So it's about a circle approach that you test. What is the quality of the building, what we should do as decision making between normative and positive indicators, sensors, tags, and look what it looks like into a life cycle. I'm to the case study. I'm going to go straight forward to the interesting, but you have the main concern about the main, I would say, answers, better quality of, and reliability of the data. That's with using that system, we have demonstrated that many times in many organizations, hospitals, cities, infrastructures, SNCF, so trains, airports in Amman in Jordanie, in Paris airport, Nice airport, Montreal, Quebec, Boston, Logan. So many airports have been through that. So reliability of the data, so better decision making, better oil in your motor. Strategic learning instead of strategic planning. So it's a big job, but you learn by learning, by doing things, either of having a theoretical and waterfall decision making from top down. You have a bottom up decision making. You know about that with data and everything. Dynamic over time overview of the life cycles, better understanding of the life cycle, of the 3 life cycle I have shown you. Risk and criticality management better, and new culture of willingness and responsibility. It develops that. People get more into comprehension of the system. And if we look only at and that will be my conclusion, I think. Oui. What are the needs? So maybe you know that graphic from Madame Rayworth. You've seen that before. So the idea is to list the project that would be linked to fight against that difficulty. You will find out that the prioritization is a multi-criteria, multi-causal problem solving, which is not easy to do because you have quantitative data and qualitative data. So it's not only about mathematics, or it's complex mathematics. And then you have the master plan management. So you have a certain level for the whole park here. You have 23% of ACI, Asset Condition Index. And the question is, what should we do for the future? If we keep on with the same approach, we will be with an ACI of 50% over the next 50 years. Sorry. Oops. If we want it steady at 23%, we have to drop maybe the highest ACI to lower, and the lowest one, get it grow with observation of the patient, not to let him die. And the last one is to retrofit to a level that would be more acceptable but cost a lot of money. So do we have money? Who do we steal to do the thing? So let's discuss. I'm done. It's time for a few minutes of discussion. Thank you.
Hello, my name is Aaron from Mexico. Thank you for the presentation. I was wondering if you could expand maybe on solutions that also don't necessarily involve constructing more. So as you mentioned with the example of opening the school beyond the opening hours that they usually had foreseen for it, if you have any other cases or interesting things that maybe haven't been explored of multi-usage of buildings or at different times of day, where beyond just simply using it in the same way, maybe it also has some sort of synergy, like the case, for example, of retirement homes also being childcare, and yeah, if you have any other things to add. Thank you.
Hello, thank you for your talk, Friederike from Germany. Maybe you could go to your slide about the ACI again, because I was struggling a little bit to understand what exactly it means, because you kind of put a like ratio between a stock and a flow, which is always, I don't know, a bit sketchy sometimes. But and like what would be maybe some examples of a building that is in ideal? Like what are the characteristics? What does this say about the usage value versus the asset maintenance structure? So I don't know, I'm just struggling to imagine any examples of how you could interpret these things.
First, with the usage part, it's a very, very important thing that we're doing more and more into our audit, is to look at the functionality and usage of building within the existing space and what we should do. And with technical, I will give an example, very simple. Before the COVID, I had an ex-student who called me and asked me, could you help me? I have a big office building where we have a big computer that will close the lighting at a specific time, and we will manage energy with lighting like that. Then came the COVID, and he called me and he said, I'm done with my project. I said, you're done? Yes, we dropped the computer to the garbage, and now we included into the contract with the cleaning company to be sure to close the light wherever they go before leaving. Why? Because we have spent the hours of use of the building because of COVID. Because of work at home, we don't have people all the time in the building, so we manage it. So it was a human-induced solution instead of keeping a very hard technology. He was not able with his computer to program the change of use every day, every week, so it was too hard. So he went to low-tech with his contract with the housekeeper. With the ACI, you're a smart student, but if you're really smart, you will read, and unfortunately, maybe I will lower it like that. Those are stocks also, stocks and stocks. We're talking about capex need. So we're talking about component or system that will be there for many years. So that will be a link to the depreciation of the building. If you replace a roof, for example, it's not day-to-day current maintenance. Maintenance day-to-day would be OPEX, and this would be flow, because you have to clean, you have to change a filter into the air conditioning system. So it's much more about the flow, and there you have the capex flow, I would say. You understand? So those are two on the same base. Those are two stocks. Okay, you can. Send me an email. It's a flow, but over a period of time, which the accounting consider it as a stock. You see, so you might induce the fact, and it's true. Where is the threshold to determine if it's a flow or not? So more you have inertia, the stock will be longer. If you have, and you're right, with the sensors, for example, I showed in the buildings, more you have sensors, every 5 years you have to drop it in the garbage. So this is flow. This is not capex. So it's there's a bit of a negotiation with the threshold.
I'm Enzo. I'm from Brazil. In your presentation, you talked about the difficulty of planning infrastructure in a democratic context because, well, governors would, presidents, whoever is elected, would plan infrastructure for a long period, but their mandates last for, I don't know, 3-4 years. How to overcome this? Like, how to promote long-lasting infrastructure planning in the context of a democracy?
Hi, I'm Haley. I'm the American. I was wondering if you could talk a little bit more about the policies that I think the city of Paris, I don't know if it's national as well, has put on like energy ratings and kind of the emissions from buildings and things. And so the one that comes to mind is particularly the energy ratings of buildings and then the need to retrofit and everything. Yeah, I mean, I have several questions. I guess the first one is, this is maybe a dumb question, but like the process of retrofitting, bringing in all the new materials and everything, has kind of the material like costs and potential emissions of doing that been calculated compared to the emissions that those low energy buildings are, emitting? And then secondarily, do those processes and those projects also come into that 5-year timeline that you're talking about, or did I misunderstand kind of like the life cycle of these different initiatives that they're undertaking, or is it kind of being done with a longer term life cycle and being envisioned?
Thank you for the question. For Brazil, it will be, the answer is here, willingness and responsibility. So the only way to get into willingness and responsibility is either having laws, so law can implement new way of doing things, or education. And with education, I can assure you that on that project here, it's a real project here. It was 226 schools over the region of Montreal in Quebec, Canada. And when they saw the catastrophe of not going the good maintenance in the past years, they were stressed about the risk. And risk language, risk discussion was a real spark plug to have new policies. If we don't manage risk, even though we're there only 2 years, we can have a real problem with incident coming. So education, so culture of the organization, and laws maybe to force a little bit the willingness and the responsibility. Okay, I answered your question? Or was it a different aspect you wanted to? Not easy to do, huh? And for Miss USA, we do have certification of buildings, like you have in the States with the LEED certification, LEED certification, for example. So it's the same thing here, and we have measurement of energy consumption and CO2, and we tag that to every building. It's even in the contract when you buy a building or lease a building. The main problem they have found with that system is that you had a big market to evaluate those things, and you had poor evaluators sometimes, poor assessors. So the quality of the result is not like you would like to. That's the first observation that we see. So it's could be perfected. The other aspect is that you have to be careful when you have a system, which a building is, to not induce new problem. For example, if you put new glasses, new windows into an old building and you don't do ventilation, you will have moisture on the walls, and the walls will want out within 10 years. So sometimes better do nothing than do things that are contrary to the reasonable. So that leads to that your other question. Yes, when you observe what are the needs over 5 years, you do have now to design over 2 generations maybe. So you take in consideration the CO2, the energy. Still, the CO2, like you were asking, is a very complex thing to measure. And sometimes you have a paradox. For example, with one of the students at GSU, she was into a project designing a port in Colombia to have bananas in Europe. And when you look at the CO2 of the project, it was pretty good. When you look at the CO2 of the whole round, it was not a good project. So it's always about the scale and the way you measure things. So it's not an easy task to do, but we're trying. As engineers, we're trying to do that.
Sylvain from France. I didn't understand the 15%. For the you have this on the picture. You get only 15% of the necessary budget to deal with all the problems. And you said that, well, you have to make choice, but there are risks that you have to compose with. But if it's a bridge, for instance, you have to admit that it may fall, or what to do. I didn't understand really.
First, this is the representation for cities in France. Over 500 cities that we've been through. When we go over what they need to retrofit and what they have as money, it's that ratio, 15%. So that's a fact into cities in France. Might be different in the US or where else. Sometimes it could go up to 40%. But when we see it's at 40%, it's because they are into a retrofit period. It will come back to maybe 15% within 2 or 3 years after that period of maybe 2 or 3 years of intensive trying to catch up. Okay, so the risk, I did not show that on that presentation, but we have a way to estimate, evaluate qualitatively the risk and to see what is the consequence of not doing things. Will the bridge fall? Very high risk, very high consequences. You will be there. Okay, so it's all about that. And sometimes you have gray zone between this and that, where you could have risk, and it's where you convince the government or the organization to put a little more money. Or you convince to sell infrastructure, but you give the problem to another one.
Thank you very much for the talk. I'm Lucien from France and the UK. So the question is born from my experience 4 years ago during my bachelor's. I was part of a group of students that was working on, well, exactly what you talked about, just the way the university was using its infrastructure and its development plans and its master plans, etc. And we encountered all the things that you talked about, all the difficulties organizationally to plan this within the university. But one of the things some person at the university told us was that because it was very old buildings, they mentioned the fact that actually lack of use was also one of the reasons for the depreciation of the, I mean, what you would call the depreciation of the usage value of the building. Whereas when you were talking and presenting the 3 parameters for this, you mentioned like endogenous use, so the intensivity of the use, which I understood as, you know, if you're using it a lot. But I was wondering to what extent a lack of use of a building also affects its quality and how quickly it will degrade.
Many cities in France had a small spot for the association to have their activities in. very low time of usage, maybe 3 hours a day in the good part, and sometimes 3 hours a week. So most of those sites have been sold, and they have built a unified complex where they have schedule now, and they densify the usage, and now everybody can go there. It gives a little problem with the transportation, and it redistribute the card, I would say, but it is one of the solutions. In that park here, we found out that they could sell or destroy, alienate, we would say, the term would be, 20% of their parks right now. But if you look at over 10 years, they would have a gain back of the population in their buildings, so maybe 10% they could drop. So that usage aspect is a very, very important aspect, and very hard to estimate and to collect and to measure. Thank you very much, if it's done. Thank you.